Friends, so today we're going to discuss problem D from Codeforces round 648, problem name Solve the Maze. So Vivek has encountered a problem in which you are given a maze represented by n cross m grid. So in the grid you can encounter these following symbols in which a dot represent that position in that grid is empty, hash represent a wall, G represents good person and bad represent bad person. Okay, so now you can only escape from the maze if you are at the cell n. So n like n comma n, n comma m. So that's the last cell of that grid. So what you have to do is you have to escape all the good persons from the grid, and you don't have to escape all the bad person from the grid. So you have what you can do here is in the grid you can form walls, because walls represented by hash, you can form some walls in the grid such that you have to block every bad person from getting out of that grid, and at the same time you want to allow only the good person to get out of the grid. If that configuration after building all the walls, if all the good person can escape and not all the bad persons, then it's fine, else you have to print no. Also, it is guaranteed that the last grid point n comma m is empty, but Vivek can also block that cell. So you can easily think that if you block the last cell, which is the exit point, no one can escape. Okay, so these are some test cases. You can go through it, but I will tell you some key insights which you can easily see. If there is no good person in the grid, if there is no good person in the grid, then you can easily say that there is always a way present, because if there is a bad person, or if the grid doesn't contain any person, because it doesn't contain good person, it will only contain bad person or it will contain no person. In both the cases, if you just block the last cell, then the answer is good, because there is no person in the grid which is good and all the bad persons are blocked. So the answer is true, which is yes. But if there are some good persons and bad persons, we have to first ensure that all the good persons should not be blocked from getting out, and we have to block all the bad persons. Okay. Now, if you want to block all the bad persons, every bad person has all the four cardinal direction in which he can move. So he can move top, bottom, right, left. But we want to check that he cannot go out of this grid. And also what we can do here is, for every bad person we will check whether there is an empty place. We will make it hash such that we will block all the positions for a bad person in all the directions. If it is out of grid, we will not do anything, because this is out of grid, this is out of grid, but this is inside the grid, and we will convert every dot to an hash for a bad person, such that he will be enclosed in all the four directions. Why will we doing this? Because if, let's assume, there is one path open, because if we are not blocking this, we are assuming that good person will go through it, then at the same time bad person can also go through that path. Why? Because bad person can go in the same path in which good person has gone, and he can reach out. And if we don't block all the four paths of a bad person, he can go out in any of the ways. If there is some path available, he can go out. So we have to ensure that all the four paths for a bad person is blocked. So what we will do is we will iterate over the whole matrix, and whenever we found a bad person, we will make all its four cardinal directions which are inside the grid to an hash, such that he cannot leave. Now after that, we will be left with a grid in which there will be good person, bad person, hashes, and some empty places. Okay. After making everything hash, as you can see, this last point, which is a initially dot first, is converted to an hash. And it means that in this case, we have actually converted the outgoing point, or the last chord, like the last cell, to an hash. So if the last cell is converted to hash, no one can get out, even the good person and bad person. So in this case also the answer will be no. There will be no configuration possible. In this case, for this bad person, because there is a good person, we will not do anything. This is in hash already. So for this person, because this will be out of bound, so we will first make everything hash. This is hash already, this will not get converted, and both down and left one is out of bounds, so we will leave it. So this will be the final grid after making everything hash for the bad person. Now what we can do here is we can make a visited matrix for every position starting from the last cell. We will mark whatever cells we can visit from starting from this last cell. So we can use BFS here. We can make a queue. We can first push the last cell index, and then we will push all its four. We will check all its four cardinal directions, and we will check whether if it's inbound. These two are not out of bound. If this is inbound and both of them are dot or good or bad, we can move to this position. But if this is an hash, let's assume this is an hash, from this, because this will always be non-empty, this will be always be open, this is always be empty, which is a dot. From this dot we can go up or this direction or in any other direction if it's valid in this grid. So if we go up and we encountered a wall, we will not move more in this direction, so we will not push this in the queue. But because this is a dot, we can go here, push this coordinate in the queue, make this visited, means that I can visit from starting at this point, I can visit to this, and then we will do the BFS same at this point and everything. After that, the whole matrix will describe all the points which can be visited. So let's assume this is a matrix. We will first check we will first push this direction or this coordinate, and we will make like this can be visited, this can be visited. This is an hash, so this cannot be visited. Now let's assume this can be visited, this can be visited, and this is an hash, so this can be visited. This is an hash. So as you can see, we will mark all the points using BFS which can be visited. If we start from this, we can go all these points. Now we have this original matrix which consists of B's which denote bad person, good person, and their original position. And we also know a visited matrix which can tell if we are at a position which can be visited. So we can go from this point if it's visited, which means that there is a valid path from this point till the end because it is visited. We have done a BFS. Now what will be our final condition be? If we find a bad person at a visited point, that bad person can get out of that matrix, so that condition is wrong. And if a good person is at a non-visited position, which is not visited, then that is also bad because that person cannot get out. So these two conditions, after we made our matrix in this form in which every bad person is captured, we will run a BFS on this matrix, which will, after running on this matrix, we will get a visited matrix which will tell from the last point what all coordinates we can visit. And the final condition will be for every bad person he cannot get out of this matrix and every good person should get out of this matrix. But if this two condition doesn't happen, we will print no, else we print yes. So I'll take it to the code now. This is the is valid function which will tell whether we are inbound. This is the solve function. We will take the character input. We will first check while taking the input how many good characters are there, good persons are there in the matrix. So whenever I'm taking the input, I will check if it's G, we will increment the count. If G is equal to 0, which means there are no good person in the whole matrix we have taken input. As you can see in this, if there is only one dot, or if there is hash, or as you can see in this last case, hash B dot. In this, if we just put a hash there, it's pretty good there. So if there is no good person, there will always be a way and we print yes. Else what we will do here is we will iterate over the whole matrix, and whenever we find a B, we will move in all its four cardinal directions, I plus 1, I minus 1, j plus 1, j minus 1. and we will check whether this cardinal position, because this is B, I comma j is B, which is a bad person. If all the four directions for B, if it's valid and it is a dot which is empty, then we will make this position equal to hash. After that, we will check whether the last position becomes a hash in this process, which I have told you in this example. If the last become hash, we will print no, because we have actually in this means put a blockage on the last point, which will lead to answer no. Else we will make a queue of pairs, make a visited matrix, mem set it to false because nothing is visited first, push the coordinate of the last exit point, make it visited. We will do a while loop till queue is not empty, take out the first element from the queue, pop it out, stored in an ij, because I actually copy pasted this code only, that's why I used I and j. We will check all the four cardinal directions for I and j, whether, because this is the point which we have visited and pushed that in the queue. Then from that point we will go all the four cardinal directions. We will check whether I plus 1 is valid, it is not visited, and like if it should not be equal to hash, because we will only visit the next cell, we will only do a BFS. If it is not visited, if it's visited, we cannot do a BFS there. Also, it should not be a wall. If it should not be a wall, we will push that in this queue, we make this visited, and we will go on. We will do it in all the four cardinal directions, and after that we will get a visited matrix of what directions we can reach. Then we will make our answer equal to true. We will iterate over the whole matrix, visited matrix again, and we will check two conditions. If any of the ith, if in the original matrix which is aij, if we found a good person there and the visited matrix shows that there is no path for the good person to go out, which is negation of visited matrix, or else if there is a bad person and there is a path for that bad person, the visited matrix shows true, then in both of these cases the answer will turn out to be false and we break out of this loop. Else if we don't hit this condition, the answer will be true. So the cout will be, we will check answer. If it's true, we will put yes, else we will put no. I hope you understand the logic as well as the code. If you still have any doubts, please mention down. Thank you for watching this video. I'll see you in the next one. Till then, keep coding. Bye.